Quick update from the Protein Vis project. We've implemented a sorting view that allows you to grab the distance matrix and then choose a certain multiple from the folder provided by yourself. And then we can then view all of the proteins that are similar in order of similarity. So to show you to do that, I'll first select the multimers folder. We'll then generate the matrix based on that folder. So we'll just wait for that to process. And we're also looking at implementing methods soon that will pre-generate this matrix so you won't have to press the button each time to do operations like this. So now that we have the matrix generated, we can now go in here and you can see each of the files in the multimers folder. So for instance, if I selected ranked 5, it now brings up ranked 5 here as the first protein. So what it has done here is it's grabbed all the data from that matrix and all the translations, and it's got all the point match data applied to all of the proteins in this list. So each of the proteins as I go along now, they're all point matched to the first protein here, which is ranked 5. So I've given it sort of a similarity index. So we say this is a similarity of 0, meaning it is the same protein. So as we go across here, we can see that the similarity index will go up one by one. And we can also then get the names of the proteins above. So as you see, we go across, you can also notice that they all have the same translations and rotations. So that's the point match data being used. So now we're able to just see the slight differences between each protein. So here I am just going across, and you can really see how different the protein gets as we go across. So now I'll just show another protein in a moment. Alright, so this time we will choose, let's say, ranked 20. So here it's brought up ranked 20. And same thing again, we can just go across and we can view them in order of similarity. And this time they're all point matched towards ranked 20. So in this example here, this ranked 0 has been point matched towards ranked 20. So on top of that as well, we've implemented a rendering distance. This is sort of in the prototyping phase, but for instance, I could say 0. Now, what that means is how many proteins on the side of the one that's being viewed are displayed. So if I hit 0 now, you'll see that we only just get the one protein that's in view. So I can continue to go across. And it sort of gives a more interesting view. I think it helps you kind of scope in and view the differences a bit better. And then of course we can just open that back up to 1. And now it's just displaying one protein either side in the visualization. For our next function I'm going to demonstrate is the blending of proteins. So I've created a formula that interpolates the positions between two proteins that have the same atoms. So we can go to our Excel sheet here, and this is just information that's taken from that distance matrix. So here we have them all compared to rank 0 in order of similarity. So for this example, we're going to choose, say, ranked 14 and ranked 16. So I'll just enter in those values here. You wouldn't have to do this in the future. This is just for prototyping at the moment. Alrighty. I'm just generating the matrix. And once again as well, the matrix data will be pre-saved future, so you won't have to generate the matrix each time and wait that period. So now that it's generated, I can blend the proteins, so we'll just select that. Okay, now that we've blended the protein, we have this protein viewed here. We have a sliding bar. So what we can do is we can start to move this bar and we can start to morph the protein towards protein B, or in this example, protein 16 versus 14. So here what we're viewing is actually rank 16 to your right of the sliding bar, and then to the left would then be 14. So all the in-between frames are just interpolations between the two proteins. So I can actually move between them, and we can see how these proteins would have to sort of move and translate to become each other. Another interesting thing we can do is we can move around the protein, and we can continue sliding the bar to understand how it morphs. So I think that's really interesting, just watching the proteins move like that. I think it gives a better idea as well how dissimilar two proteins may be, or even how similar they are. Further improvements to this function would also include having more frames between more interpolations, so it'd be more of a smoother animation in the future. So I'll just give another quick demo with two more proteins. So we'll go back to our Excel sheet, and this time we'll select two very dissimilar proteins. So in this example, we'll select ranked 1 and ranked 10. So coming back into here, ranked 1 and ranked 10. Running the program again. So here we can see ranked 1 versus ranked 10. So here's ranked 1 and ranked 10. So we can see there's actually quite a lot of fast movement going on here to morph the two into each other. That just shows how dissimilar the proteins are. You can see the morphing actually having to shrink and then expand the protein back out, which just shows how different these proteins really are from each other in terms of how they've been laid out from AlphaFold. Once again, we can just move around the protein to get other aspects and views. So that's our progress update for now. So to recap, we implemented a sorting view that allows you to go through that point match data, and you're actually able to see all of the proteins from that folder in the same orientation, which enables you to see which proteins are similar to which other proteins within the same folder of multimers. And then we also implemented the blending view, which then allows you to select just two proteins and then see how they would morph into each other, which then to another level allows you to identify the differences between the two proteins. Future implementations would probably be to merge the blending view and the sorting view together, and that would sort of allow you to move through all of the sorted proteins while also getting that blending view between each of the proteins. So if there's any feedback you'd like to provide, that'd be well appreciated, and I hope to speak soon. Thanks, Kate.